Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 2.7, Problem 1. This is Section 2.7, Problem 1. It says find the least common multiple of the numbers 12 and 16. So what we want to find is the smallest number that both these numbers divide into evenly. And you can kind of guess at it and that'll work, but the mathematical way to do it is do the prime factorization of both numbers. So start with the 12, split it up any way that you see. I can see 2 times 6, so you can start with 3 times 4. The 2 is done, but the 6 will split into 2 times 3. So for the 12, I have 2 to the second power times 3. You want to use that exponential notation when you have a repeated prime. And then do the prime factorization of 16. So for 16, you can either go 4 times 4 or 2 times 8. It's going to come out the same in the end. And then both 4s can be split again into 2 times 2. So the 16 breaks down into 2 to the 4th. So now I have the prime factorization for the 12, and I have the prime factorization for the 16. Now what I want to do is look at both prime factorizations and make a list of any prime that appears in either one. So I have 2 and 3, and that's it. Now look for the exponents. Where I have an exponent, I want to choose the larger exponent. For the 2, I have second power, fourth power. Fourth power is bigger, so I take the fourth power. For the 3, I have only first power, so I'll just leave it. And then what I want to do is multiply those numbers together. So I did the prime factorization of both numbers, made a list of the primes taking the larger exponent, and then the last thing you do is you multiply them. So 2 to the 4th, I can see here, gets me back to 16. It winds up being 16 times 3. And I can do that without writing it out. It's 48. So what that means is 48 is the smallest value that both 12 divides into evenly and 16 also divides into evenly. And what that amounts to is it would be the least common denominator if 12 and 16 were denominators.